So we're going to be factoring trinomials in the form of x squared plus bx plus c. So I am just going to sidestep this question immediately anyways, and let's take a look at what really separates this form. I'd like to call this case 1. And remember, cases are when I have this really large problem that I want to discuss, a really large topic, but it's actually made up of 3 or 4 or 5 different smaller cases. I'm going to call this case 1. I'm going to be factoring trinomials. Case 1 is anything in the form of x squared plus bx plus c. Now, I'm just going to go over here for a second, and I'm just going to have fun, play a game. Now, I'm going to add or ask you what two numbers add to 7 but multiply to 6. So what two numbers add to 7 but multiply to 6? 6 and 1. So in your brain, you're sort of kicking around a bit, aren't you? Okay, so maybe let's check this out. Now, what two numbers add to -7 but multiply to 6? So there's two numbers. And then you get a little bit wise, and then you say, it must be -6, -1. See, isn't this game fun? If you are playing this game, you can easily factor polynomials using these skills. And these are the skills that we use. So you really need to know the multiplication. And we can even get it even further. So those two numbers, and I'm just going to say that multiply to and add. Okay, so that multiply to -4, but add to 0. Great question. So if two numbers multiply together and that is a negative, that implies that one of the two numbers must be negative. So what two numbers multiply to -4, where one's positive, one's negative, but add to 0? Well, that would be -2 and 2, right? Okay, this is a lot of fun. I'm actually having a great time here. Now, what two numbers multiply to, actually, let's do add, -3. Okay, -3, so, great. What two numbers multiply to -10 but add to -3? Now, allow me just to discuss what's going on with these two numbers and how they might relate to these two numbers. So if two numbers multiply to -10, that really means that one number is positive, one number is negative. And if they add to -3, well, that would mean that the one that is larger has to be negative. Well, that makes sense. Well, how about what two numbers multiply to -10? Well, -5 and 2. Right? I could have, those two numbers work. Now, if that is out of your scope here, maybe I'm going to work systematically. 1 times -10. Those are two numbers. 2 times -5. 3, nope. 4, nope. 5 times -2. 10 times -1. Now, only one of these pair add to -3, and that is those, right? 2 and -5. And if you're able to be a little bit keen with math, you got it. Anyways, this is essentially factoring. You're going to use this key, but now I'm just going to say different words. What two numbers sum? What two numbers sum to 7 but multiply? Okay, 7. Oh, yeah. That multiply to 12. Wait. Let's change this around. There we are. What two numbers have a sum of 7 but a product of 12. Now sum just really means add, right? Product means multiply. So what two numbers add to 7 but multiply to 12? 3 and 4. I get it. And if you don't, please take 12 and ask yourself, what two numbers multiply for 12? There we are. So since the product is positive, that means that those two numbers both have to be positive or both negative. But since the sum is positive, that implies that we're only going to look at two numbers who are positive, right? Boom, there it is, right there. We can stop. Anyways, this is actually a game that I play with my family sometimes, especially when they're getting used to multiplying. And then we have these fun games like, hey, tell me two numbers that multiply to 10 but add to 7. And there it is. And it's just fun with numbers. Anyways, I'm just going to maybe, just maybe, go off on a tangent. Now, I haven't really talked about the lesson yet, but I promise we are going to get there. I am going to make up a dream here. There we are. And I'm going to think of one factor, and this one factor is x plus a. I'm going to think of another factor, and that factor is x plus b. Now, wouldn't you know it? If I take x plus a times x plus b, if I multiply this out, what I get is x squared plus bx plus ax plus ab. So I'm just messing around here. I'm going to maybe put those two terms together. So this is really ax plus bx plus ab. Okay. Now, I'm going to do something really bizarre here, and this is almost like a mathematical proof. I'm just going to factor out x from these two, only these two terms. And the reason I can do that is because they're like, and I can say that the common factor is x. The greatest common factor is x. I'm just going to factor out x. So, wait a second. I have it. Now, did you know that this is equal to this? In other words, if I have some crazy trinomial, and I want to break it up into two even factors, I can always play this game. Now this is the sum. This is the product. So let's play a game. Now remember, A is a number, B is a number. Can you tell me which two numbers add, or whose sum is 7, but multiply, or whose product is 12? Well, what are those two numbers? Those two numbers will be A and B. So tell me two numbers that multiply to 12 but add to 7. 3 and 4. That's what we're going to be doing. Let's actually get ready to do